Welcome back, Geometry Scholars. Today's lesson is on interior and exterior angles, as well as isosceles and equilateral triangles. Our essential question is, how do triangle properties assist in solving real-world problems? And our lesson objective is that you will be able to apply knowledge of exterior and interior angles to find the measure of a given angle in a polygon. This lesson is vocabulary heavy, so make sure that you are paying attention to these words, highlight them if you need to, but they're concepts that you will need in order for us to progress in geometry. If you don't grasp these concepts, some things that we will continue to do will not make sense. Don't forget, if you have questions, write them in the left-hand side of your notes. First up, a blank angle is an angle formed by two sides of a polygon with a common vertex, and that would be an interior angle. And what does the word interior mean? Well, interior means inside. So think about interior being inside the triangle. Interior is inside the triangle. So a triangle has three interior angles. Here's one of them, here's a second one, and here's a third one. Okay, it's the space. It's formed by two sides of a polygon, and they share a common vertex. Share this vertex, those two sides share that vertex, those two sides share that vertex. Okay? A blank angle is an angle formed by one side of a polygon and the extension of an adjacent side, and that would be an exterior angle. And what does the word exterior mean? Exterior means outside. So inside is interior, inside the triangle, or exterior is outside of the triangle. And an example here, an exterior angle is formed by one side of the polygon. So here we have this side of the polygon, and then it says, and the extension of an adjacent side. So here is the adjacent side, and it's extending out to the right. So this area is the exterior angle. Okay, if you want to highlight those or color those, feel free to. So let's move on to the exterior angle theorem. The measure of an exterior angle or an outside angle, the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Okay, and looking back up at this image right here, okay, we have the exterior angle, and if I wanted to know what the measure of this one was, it's equal to the sum of the remote interior angles. That's a plus sign. Let me draw that better. This one is like an X. So this angle plus this angle. Okay. A remote interior angle is not adjacent. We've used the word adjacent before in geometry, or it's not touching, or it's not next to. Okay, so it's not next to, or it's not adjacent. Okay, so this interior angle right here, it's touching the exterior angle, or it's adjacent to the exterior angle. So that one doesn't count. Okay, that doesn't count as one of the remote interior angles. This one that I've circled and this one that I've circled, those are the remote interior angles. And if we added those up, that would tell us the sum of the exterior angle. So for example, if this angle was 57 degrees and this one was 63 degrees, add those up and you get 100. So 57 plus 63 equals 120 degrees. So this angle would be 120 degrees. That's an example. Okay, that's an example. Okay, and one thing I did not mention up here with exterior angles, I apologize, hopefully you caught this. And again, if you want to highlight, I highly suggest it. These are just things that will help you and they'll pop out. Exterior angles form linear pairs with the interior angles. So, for example, this angle right here that I have already, the exterior angle that I've noted in green, and then this angle right here, the interior angle, not the remote one, but the other one, together those two angles form a linear pair. And how much is a linear pair? A linear pair are 180 degrees. Okay, so linear pair. So these two angles together have to add up to 180. Well, if, for example, this one was 120, then that means the inside one is something, and together they add up to 180. So that inside one would be how much? Well, that inside one would be 60 if this scenario were correct, okay? But again, those are just examples that I put in there to show you how this works out. So, as a recap, an exterior angle forms a linear pair with its interior counterpart. So here's our nice linear pair, 180-degree line, okay? And the exterior angle is equal to the sum of the two remote interior angles. So 57 plus 63 were the remote interior angles because they're not touching the exterior angle, they're remote. Add them up, 120 degrees. Okay, I know that was a lot of vocabulary, but they're words that hopefully you're familiar with. Interior is inside, exterior is outside, so really only the remote interior angles is a new concept. Let's go ahead and practice some of this. This is something we've been doing on bell work, so we should be somewhat comfortable with this. How many degrees are in a triangle? 180. Okay, so total we have 180. So looking first at letter A, this angle right here, it's 110 degrees. Is that an interior angle or is it an exterior angle? It's an exterior angle. I'm going to code it as exterior. So can I find out how much this interior angle is? I certainly can, because the exterior angle and the interior angle together have to be 180 degrees. So if my exterior angle is 110, and I'm looking for my interior angle, I can solve for that. So I subtract 110 from both sides, 110 from both sides. My interior angle is 70 degrees. So I have solved my interior angle. I know that it is 70 degrees. Okay, so that was my interior angle. Now that I know my interior angle is 70 degrees, can I solve for my other missing angle? Can I solve for x? Yes, I can, because I know that they have to add up to 180. So I know that 70 plus 60 plus x equals 180. What is 70 plus 60? 130 plus x equals 180. Subtract 130 from both sides. X equals 50. So the value of x is 50, or x is 50 degrees. And to double check that, I should make sure that 50 plus 70 plus 60 all add up to 180, and they do. I also should double check that 70 and 110 add up to 180, and they do as well. So I am on the right track. Okay, I have been solving them correctly. Let's go down and do letter B. I'll just want a green marker so we don't get confused with what we already had. Okay. So this one, I have an exterior angle, and then I have two interior angles. I know that this angle plus this angle make 180 together, but I don't even know what the interior angle is. They didn't tell me anything about it. But if you look back up at the exterior angles theorem, oh, it's not here, sorry, exterior angles theorem, it says the measure of an exterior angle is equal to the sum of the measures of its remote interior angles. So I have an exterior angle, it's 3x plus 16, and it's equal to the sum of my remote interior angles, which is, this is my remote one, and that's my remote one, because they're inside, but they're not connected to my exterior angle. So that equals 52 plus 2x. And now I'm simply going to solve for x. Subtract 2x from both sides. I have x plus 16 equals 52. Subtract 16 from both sides. X equals 36. This is just simply solving an algebraic equation, but you needed the geometric knowledge to know how to set it up. this exterior angle was equal to the sum of the two remote interior angles. So I added those two up, and I set it up equal to 3x plus 16. Let's move on to another theorem. The Triangle Sum Theorem says that the sum of the interior angles of a triangle, not interiors, but interior angles, the sum of the interior angle measures of a triangle are 180 degrees, which you guys know that. So angle A plus angle B plus angle C together make 180. We've discussed that. We've been doing that in bell work. But sometimes we have shapes that are not triangles, not just three sides. We have polygons that are shapes with many sides. The sum of the measure of the interior angles of a convex polygon with n sides, so no matter how many sides it has, is n minus 2 times 180. So take the number of sides, subtract 2, we'll multiply it by 180. Let's try this with a triangle. How many sides does a triangle have? Well, it has 3 sides. So I'm going to plug in 3 with n minus 2 times 180. So a triangle has 3 sides, so 3 minus 2 times 180. What's 3 minus 2? 1 times 180. 1 times 180? 180. Okay, and that is true. Are the measures of a triangle, of the angles of a triangle, 180 degrees? Yes, they are. So we've just proven that theorem with a triangle. Let's go ahead and practice. So what we're going to do here is we're going to find the sum of the interior angles for each of the following, and we're going to draw the diagonals from any one vertex for each polygon. And the first one is done for you. We started at this vertex, and I have to draw a diagonal to the other vertexes. So if I do that, I'm going to go here. Oh, let me put little points. I'm going to go there and there. How many triangles were made here? Just 2 triangles. So 2 triangles. And your purpose of this is to see how many triangles you make. So did I really have to draw that line and that line? No, I didn't. So when you're drawing these triangles, you only have to start with one vertex. So I'm starting right here. I do my little arrow. That's the vertex I'm starting at. You only have to draw a diagonal to the vertexes that are not adjacent to the starting vertex. So I don't need to draw it here or here, because drawing it there or there is not making a triangle for me. Okay? So since I have 2 triangles, how many degrees do you think this polygon is? Well, 2 polygons, and how many degrees are in each of the triangles? We just know, we just proved it's 180. 2 times 180 is 360 degrees. So let's see if we're right. Let's by using the formula. Remember, the formula is n minus 2 times 180. So n minus 2 times 180. What does n stand for? The number of sides. How many sides does this polygon have? 1, 2, 3, 4. So 4 minus 2 times 180. What is 4 minus 2? It's 2 times 180. What's 2 times 180? 360. So yes, 360 degrees, we got it both ways. Okay. I'm going to do letter B with you, then I want you to try letter C on your own. I'm going to start with this vertex. I'm going to draw a diagonal here and a diagonal there. I see 3 triangles, and 3 times 180 degrees should be 540 degrees. Let's see if I'm right. N minus 2, so let's count the number of sides. 1, 2, 3, 4, 5. So 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180. 540 degrees. 540 degrees. I got the same answer both times. So this right here is the formula that you should be using. But it's important to recognize that that's the formula because we're working with triangles. We've broken the shape up into triangles. So I want you to do letter C on your own. I want you to draw your diagonals from one vertex and then also find the number of degrees of the interior angles for the polygon. Okay, you should have drawn 4 diagonals, which results in 5 triangles. There were 7 sides, so 7 minus 2 is 5. 5 times 180 is 900 degrees. So the sum of the angle measures, of the interior angle measures, is 900 degrees. Let's move on. Second page, Isosceles triangle theorem. If 2 sides of a triangle are congruent, then the angles opposite them are congruent as well. So this side right here is congruent to that side. So the angle opposite this side, if you follow it over, is this angle right here. And the angle opposite this side is this angle right there. So if the 2 sides are congruent, the angles opposite those sides are also congruent. The converse of that is also true. If 2 angles of a single triangle are congruent, then the sides opposite them are also congruent. So here's my angle. If I follow it over, that side, here's my other angle, follow it over, is congruent to that side. So if the angles are congruent, the sides opposite to them are congruent as well. With an equilateral triangle, equilateral means all 3 sides are the same. So if it's equilateral where all 3 sides are the same, marked with 1 tick mark on each side, then it is also called equiangular. And that means that they are also equal angles, okay? Angular angles. So all their angles are the same also. So if triangles have to add up to 180, and there are 3 equal angles, how much is each angle worth? What's 180 divided by 3? Answer is 60 degrees. So if it's equilateral, it's also equiangular, and each angle is 60 degrees. 60 degrees. You never have to even wonder if all the sides are the same. Let's go ahead and do example 3. We're going to find x. Well, I know that this side is equal to that side, so that means this angle, which is across from this side, is equal to this angle, which is across from that side. So this one's also 46 degrees. So can I now find x? Sure, because x plus 46 plus 46 have to add up to what? 180. Okay, so x plus 92 equals 180. Subtract 92 from both sides. X equals 88 degrees. Okay, let's try letter B together. And then you're going to do example 4 on your own. I know that this side is equal to that side, so the angle across this angle is equal to the angle across here, this angle. So that means since that side was x, this angle has to be x as well. So x plus 3x all have to add up to what? They all have to add up to 180. At least we know the measures of a triangle angles are always going to add up to 180. So x plus 3x is 5x. 5x equals 180. Divide x by 5 and then 180 by 5. X equals 36. Oh, it's actually not 36 degrees. Oh yeah, it is. X equals 36 degrees. So x is 36 degrees, x is 36 degrees, and then 3x will be 36 times 3, 108 degrees. Okay, and we can double check by adding 36 plus 36 plus 108 together, and it should add up to 180. We're going to go ahead and try example 4 on your own. Find x for letter A, and then find x for letter B as well. Please pause the video and try it on your own. Okay, with this first one, if angle U and angle W are both 60, that means angle V has to be 60 as well. So if all the angles are the same, that means all the sides are the same also. So all the sides are equal. So, sorry about that. So that means that 2x minus 3 is equal to 7, because that means this right side has to be the same size as this bottom side. So the right side was 2x minus 3, but I know the bottom side was 7. So I can set it up as an equation. 2x minus 3 equals 7. Add 3 to both sides. 2x equals 10. Divide by 2. X equals 5. Okay, so if you had a hard time with that one, letter B is the same thing. Okay, go ahead and solve for x on letter B. Set it up as an equation. 10x plus 3 equals 3x plus 24. Subtract 3x from both sides, and then subtract 3 from both sides. You get 7x equals 21. Divide by 7, x equals 3. And that brings us to the end of our lesson. Please make sure you've written a summary. I want to quickly go back. We talked about interior angles are inside, exterior angles are outside. Exterior angles form a linear pair with the interior angle that is touching. Exterior angles are equal to the sum of the two other interior angles. They're called remote angles. We also we did some examples where we found the measures of angles, which we've been doing on bell work as well. We also talked that triangles, the angles inside add up to 180. And then the formula for a polygon is n minus 2 times 180. That's a formula we will use multiple times. We practiced that. We drew diagonals from the vertexes. Isosceles triangles, if the two sides are congruent, and the two angles opposite of those are congruent. And the same thing is true if the two angles are congruent, then the two sides opposite those are congruent as well. Equilateral means equal sides. Equal angular means equal angles. And then we practiced. Okay, so make sure, please, you write a summary. If you have any questions, write them down. We'll answer them next class. Have a great day.